So this question, we are asked to look at the topic using truth tables to determine the validity of an argument. So here we've got an argument written out based on these two statements, P, that the conference is in Tokyo, and Q, that Anne is an organizer. And so the argument is written in the form of, we've got premise 1, premise 2, and then based on the premise 1 and premise 2, we have a conclusion. And so we're supposed to read those premises and then decide whether or not this argument is valid. And we'll talk about how to do that here shortly. But first of all, just in real simple terms, how do we write the argument in symbolic form? Well, when you look at this first premise, it says the conference is in Tokyo. That's exactly what statement P is. So this premise 1, I'm going to write it over here, is P or, so that's the or symbol there. Remember, that's the disjunction. Or what, Anne is an organizer, and Anne is an organizer is exactly what statement Q is. So that premise 1 is P or Q. And then statement 2, or premise 2, is that the conference is in Tokyo. So if that's just statement P. And then the conclusion is this little 3 dots that's in mathematics that means therefore. So in other words, based on premise 1 and premise 2, we're saying therefore what? Therefore, Anne is not an organizer, so that's just the negation of Q. So therefore, not Q. So there's how we write the argument in symbolic form. Then, moving down, let's scoot that down just a little bit. There we go. Then we express the argument as a conditional statement in this form. So in other words, premise 1 and premise 2 then implies, that's the conditional statement, this conclusion. So to build that as a truth table, we'd have to do some rewriting here, and I'll squeeze this in this way. We've got P, we've got Q, and we're going to have to add some columns here, and then I'll write this conditional statement that was P or Q and Q. Sorry, and P, looking back, then implies not Q. So that would be the rewriting this. So there was premise 1, P or Q, and then premise 2 was P, and then those two together implies the negation of Q. So that was writing the argument in this form. Now to do that, we're going to have to build some things. We need to know a few extra columns. I didn't quite give myself enough room. So we've got P, we've got Q. We can look at P or Q, and I'll write that kind of sideways, P or Q. And so we know T, T, F, F, T, F, T, F to get all of our combinations. And then P or Q, that's one piece there. Remember, the disjunction P or Q is true if either one of them is true. So the first 3 it's true, then it's false when they're both false. And then if I look at P or Q and P, so that's the next piece. So that's just the left side of the conditional statement. So P or Q and P. So now I'm looking at these two columns right here, and I'll get out the highlighter. I'm looking at, there's the first thing I'm looking at, P or Q and P. So then we just remember that the conjunction of two statements, so in this case it's P or Q and P, is true only when they're both true. So there's true, true, that's true. True, true, that's true. False, true is false, and false, false, that is also false. And then the one last thing I need to fit in here is the negation of Q, which that's real easy. That's just negating whatever, the opposite of this column. So that's just negating Q. So that's going to be false, true, false, true. And now finally, to evaluate this overall conditional statement, which is the argument that we're trying to see, we know that a conditional statement, so I'm really just focusing on the two sides of that conditional. A conditional statement is looking at, now I'll switch colors to yellow. I'm focusing on this column as the left side of my conditional and this column as the right side of my conditional. And so I'm saying true implies false. So that is false. We know true implies true is true. And false implies false is true. I wrote false there. That's supposed to be a true. So that's a T. False implies false is true. False implies true is true. So remember, the conditional statement is true in all cases except where you have true implies false. And so since you have the truth values of the overall argument, and notice that we have one of them is false. If the argument was valid, it would be true for all of the combinations. But since we have one of them that it's false, so in other words, we're looking for this to be true, 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 all the way down. But since we have one of them that's false, we say this argument is not valid. Now, so that was just me talking this through. I'm also going to comment. I've got the ALEKS explanation pulled up, that as you practice these, I encourage you to read through. Here, I'll kind of go through this quickly. There it was showing how we break it down into symbolic form. P or Q and P. Oops, went the wrong way. There we go. P or Q and P. And then the negation of Q. Here's the truth table. And as you practice your truth tables, hopefully you've been seeing this all along. I like how ALEKS shows you just the two columns at a time that you're focusing on. And again, we're at a place where hopefully you've practiced these enough that when it makes this statement, P or Q is false only when P and Q are false. In other words, that's just reminding you, basically this is one of those patterns you're supposed to have memorized by now. Same thing here. So now we have a conjunction and you're only focusing on these two columns. And P or Q and P is true only when both of them are true, both sides of the and. And so there are those truth values. And so again, building them in the very same way that we did when we did it by hand. Same point here, you get down to the end. false, true, true, true. And so we added those extra columns as needed if you're building that thing in ALEKS. And to understand whether it is valid, the short answer is no, it's not valid because it has to be true for all values. It is important to point out a couple things. It's important to point out that whether an argument is valid, that has nothing to do whether the conclusion is true. And so there's just an example to point that out. So being valid doesn't mean that it's true. Those aren't the same thing. So one common mistake people make is they get hung up on whether or not the statement is true. That's not the same as whether the argument is logically valid. And we'll talk more about this in another video, but part of the point to this is, and we just did this one, the fallacy of the inclusive or, that if you kind of talk this one out, sometimes it's easy to convince yourself, that's what kind of a fallacy means, is that it's something that's false that people often think is true. It's easy to convince yourself that this actually would be true when in fact a truth table will prove to you that it is false. So that was just this particular one, and as you do this particular problem in ALEKS, you could end up with any one of these arguments, whether your argument was true or false. And as you practice these, the law that we give them names because the pattern comes up so often. So that one's called the law of detachment, law of contraposition, law of the disjunctive syllogism. So as you do these, look for these common patterns to occur, and look for these common invalid arguments to also occur.